Good evening, everyone. Today, I'd like to talk about the state variable layout of a smart contract. As you can see over here, if I have a smart contract called contract bars, I declare three variable. Actually, the layout is word by word, and every word is 32 bytes. So in other words, this is how the state variable is organized. So this start 0 is going to start A, start B is going to start B, so start 3 is going to start C. So yes, in Solidity, you always use the name of a variable, but in the EVM machine, they are going to not going to use the name, they are going to use the slot number. So it's going to be translated into the EVM code into slot 0, slot 1, and slot 3. I think that's helpful for security people. And by the way, you can as many as 2 to the 256 slots available for each smart contract, which is very much sufficient for practical purposes. And keep in mind, every smart contract have independent storage. So all the state variables are independent from each other. So let's just go to Remix and look at, let me see over here. I'm going to maybe pause. Okay, I have created this program over here called storage. Essentially, I create a slot 0. As you can see, it's a struct, but this struct is very simple, only you in the value. So in terms of layout, it's the same as you just declare uint over here, no difference. So the first one is uint, the second one is uint, the third one, slot 2 is uint, and slot 3, I declare 2 boolean, and because boolean is only 1 byte, so actually I can squeeze 2 boolean variable into the same slot. Okay, you will see that too. And then we are going to have a slot 4, which is integer. And slide 5 is an array. We will find out how that's stored. And then slot 6 is a mapping. So I'm going to talk about this sixth slot and see how everything works. And by the way, also in the constructor, because this is a dynamic array, I push in 4 elements, which is 4 integer. And in addition, in the mapping, I put it 2 mapping, mapping from 21 to 21 and 43 to 43. I have a few functions here. One is get hash, the other maybe get hash. I don't know. I just want to make a difference. So let's say get hash slot. Okay. And then this get is going to able to give us to read the value in a particular slot. It's a helper function. And so that's inner, this external. So I can read arbitrary slots value to see what it look like. But I want to show in hexadecimal, so I use this helper function to read a particular hexadecimal. For if I want to decimal, I use this one. If I want hexadecimal, I use this one. So we can try both one. And this one allows us to set arbitrary value for every slot. And by the way, probably by now you know every slot can be declared public and private. This is only compiler restriction. At the virtual machine level or blockchain level, every slot is readable and there's no secret. So don't expect just because you declare private, you're going to have privacy. There's no privacy. They are all accessible in the virtual machine. They are readable. So let's compile and then let's deploy. What's going on here? Constructor. Let's say public. Okay, so it compiles now. So let's go back here and then we're going to deploy this and then or to, I'm just going to make sure I have the right version, because sometimes the previous version might be confusing. So over here, we're going to look at one slot at a time. So let's say I want to get a first slot. It's going to be 1, 2, 3. Okay. So I'm going to say, which is 0. It's 1, 2, 3. That's is expected. And then 1 is going to be 4, 5, 6 expected. Okay. And then slot 2, 7, 8, 5. And then slot 3 is going to be a little bit interesting because it's going to combine two of them together. It's going to be 257. Why? Because it's the last 2 bytes are going to be used. If you use this one might be more obvious to you. So if you see this, you are going to see the last 2 bytes. This is 0, 1. So this stands for the, so as you can see, it's a right aligned. So it's padded with a lot of 0 in the beginning. So it's right a line over here. So this true means this true, okay, and this true means this true, okay. So that gives you some idea. So let's look at the next one. Start 4 is going to be 99, and then slide 5 is a little bit interesting because why? Because it's not going to store all the value at the slot 5 because it's a dynamic. So where it's going to be stored? Well, actually, slot 5 only going to store the offset. Okay, so in other words, it's only going to store the pointer. So what is the point over here? It's going to be so where those values 33, 34, 35, 36 are stored. They are actually stored in the hash of slot 5. So we need to calculate the hash value of slot 5 over here, which is calculated by this function. It's a hash of the slot. So slot 5 hash is going to be hash. So actually it's a bigger number. So this is actually these 4 values are stored. We can verify that. Okay, so if I put this slot number over here, as you can see, this is the first value. See that? And then uh, and then but what is the slot 4 stored? Slot 5 actually also stores something. If you check slot 5 over here, if you check slot 5 over here, let's see. Right, it's going to store how many. So slot 5 actually stores something, which is a number of elements for this particular way. But the real elements actually stored to another slot, which is calculated by the hash of the slot number. So again, it's over here. And then if you say plus 1 over here, it's the next number, 34. And 2 again, it's going to be 35. And 3 again, it's 36. Okay. So that's how we store the dynamic array. Now, what about mapping? Mapping is also dynamic, right? Because you can store as many keys as you want. So in this case, it's going to be 6. So do you expect the slot 6 is also going to store the number of mapping? Actually, no. The mapping never remember how many mapping are stored. Not like the dynamic array, you do remember how many elements are stored in dynamic array. So as a matter of fact, so it's actually just 0. You don't store anything here. But still, we need to store the use it as placeholder because in this place, as a matter of fact, it's going to use another get hash slot to calculate where the mapping is stored. The mapping is going to be stored in the for each key. It's just not the same, not like the array stored all together, right? Just plus 1. But mapping is every value is stored totally in a different slot. So it's not going to be all together, not contiguous together. As a matter of fact, for every one, for example, 21 is stored in one place, 43 is totally in a random other place. Not saying random, but you can calculate by, like, say, if this one is stored, it's going to be stored in 21 using the hash slot of this function. So it's going to be a hash of the concatenation of key and a slot. So it's going to be 21 and the slot number is 6. So I'm going to get that hash slot. So it's 21, which is the key. And the concatenation with the key is, in this case, is 21. So it's been 21 over here. All right, I'm sorry. A slot is going to be, slot number is going to be 6. Okay, so this will be the real slot number where the first mapping is stored, I mean the value. We don't store the key, we only store the value. We don't store key at all for the mapping. Okay, that's a little interesting, huh? We don't store the key, we only store the value. So now you can get, I'm going to use this to use a decimal one. So now you retrieve 21. And what about 43? Well, 43, you have to calculate again for the store number for 43, which is going to be the same, but change this to 43, and you still use the same store number. So this is why the store number for the mapping is still important, the store number. Although you don't store anything in this store, but the number is still used to calculate where the particular value for key is stored. So now you calculate again. Now this is where the value is stored for this particular key. And if you read it over here, you're going to get exactly the 43 value. So in summary, dynamic array, you store the number of elements, but you don't do that for mapping. For the dynamic array, we store all the value together, although in a different slot. But for mapping, every value is stored totally in a different slot, not even together. And the way you calculate it is by this function, by the hash of the key and the concatenation with the store number. And then the key is not stored, only the value is stored. So for every value, you have to calculate where the stored is using the hash of the store number of the mapping as well as the key value to calculate it. All right, so that very much summarizes how the slot works in Solidity. Thank you so much. Have a nice day.